import beacon from sklan.model selection import train test split from Skyv import miscellaneous import np import os label equal to os list directory dataset image label equal to label of 1 colon dataset 2 for image label images os list directory of dataset image plus image label for image and images image equal to miscellaneous im read image read dataset underscore image plus image label plus image miscellaneous image resize image 64 comma 64 dataset append image comma image underscore label x y for input image label in dataset yes append input y append of label index image underscore label x equal to np array of x y equal to np array of y x train y train equal to xy dataset x train y train save label open initialize to word out pickle wb pickle tab label save label close. The training of images helps in storing their recognizable patterns within specified loader. Import np import matplotlib library dot py plat as plat lt from keras dot layers import dropout from keras layers import flatten from keras constraints import max normal from keras optimizers import sgd from keras layers import conversion 2 dimension from keras layers conventional import maximum pooling 2 dimension from keras utilization of import np utilize from keras import backend as k import load data from keras models import sequential from keras layers import dense from import keras k set image dimension ordering tf fix random seed for reproducibility seed 7 number random seed load data x train y train equal to load data dataset normalize input from 0 to 255 find 1 g 0 minus 1 x train as type flat 32 x test as type flat 32 x train divide 255 x test equal to x test divide 255 on hot encode outputs y train np equals to categorically y train y test np utilize to categorical y test number classes y train shape create the model sequential model add addition of conversion 2 dimension 32 in of 32 of 3 comma 3 input shape 64 comma 64 3 padding save activation relu kernel constraint maximize normalize 3 model 1 add dropout of 0.2 model add conversion 2 dimension 32 comma 3 activation relu padding save kernel constraint maximum normal of 3 model add maximum pooling 2D pool size 2,2 model add flatten model add tens 502 activation RLU kernel constant maximum normal of 3 model add dropout 0.5 model add tens number classes activation softmax compile model epoch 10 I rate 0.01 dk I rate epochs SGD I rate momentum equal to 0.9 dk equal to dk net Nistro false model compile loss categorical cross entropy optimizer SGD matrix accuracy print model summary callbacks keras callback early stopping monitor equal to volume loss minimum delta equal to 0 patience 0 verbose 0 mode equal to auto callbacks keras callback tensor board of log directory equal to logs histogram frequency equal to 0 patch size 32 write graph true write grades false write images true embeddings frequency 0 embeddings layer names null embeddings metadata none fit the model fit extract weighted epochs epochs batch size 32 shuffle true callbacks final evaluation of the model scores model evaluate x train y train verbose equal to 0 print accuracy scores serialized model of JSONX model JSON model to JSON with open model face JSON comma W as JSON file write model JSON serialize weights to HDF file model save weights model face H5 print save the model to disk. The above line code generates as an output as shown below. Tensor image recognize Python trophy using TensorFlow background. I write. Layer type output shape parameter conversion in layer type conversion 2D 1 conversion 2D none 64 32 896 parameter dropout 1 none 64 36 here parameter 0 conversion 2D save here parameter 9248 maximum pooling 2 none 32 0 here is only different from above flatten none 32768 0 tens none 512 parameter 16777 288 dropout none 512 0 tens none to 1026 total parameter 16,788 dot 898 trade label parameters 16.788 898 not tradeable parameters 0 assume your CPU supports instruction that this in TensorFlow binary was not compiled to use various coming on the output. A book, it is out, depends upon system. A book 1 by 1, 1 by 10, compiled 2 by 10, 3 by 10, 4 by 10, up to 9 by 10. 2 years step loss accuracy. This is the step loss, how much accuracy. 1. This is loss. Here work 1 by 10. 2 years, 2 years, 2 years loss 1.3793, accuracy 0. 2 by 10, work 1 by 1. 2 by 10, 3 by 10, 4 by 10, 10 by 10. Here, showing according to steps. 360 step, 44, 325, 328, 319, 325, 328, 321, 39, 379 step. Loss 1.91, 91, same here also. Accuracy also same. So recommendations for neural networking training. In this chapter, we will understand the various aspects of neural network training which can be implemented using TensorFlow framework. Following are the 10 recommendations which can be evaluated. Backpropagation. Backpropagation is a simple method to compute partial derivatives which includes the basic form of composition best suitable for neural nets. Backpropagation example: input layer, hidden layer, output layer. This is weightage, all are weightage. So wij, 1j, w1j, w1j, w2j, sorry, 1i, 2j, 2i, 3j, 3i, jk, ik. So according to this value, 0.20 to 0.50. Assume w jk 0.125. Assume one instant 1.0.4.07 with the actual value 0.65 in the data set. We feed it in the network step 1 and compute the network output value. Output is 0.582 and then error 0.652 minus 0.582, so total 0.068 error. For this instance, step 2, step 3, the propagation error 0.068 from output node k backward in the network, updating the weights. Section 8.5 provide technical details. Updating the weights is optimal. Stochastic gradient descent. A batch is the total number of examples which a user uses to calculate the gradient in a single iteration. So far, it is assumed to be that the batch has been n-dash dataset. The best illustration is working at the Google scale. Dataset often contain billions or even hundreds of billions of examples. Gradient descent, stochastic gradient, SGD, red color, like this. Gradient descent, like this. TensorFlow.